Your heart beats. Your blood flows. But how does the physical friction inside your blood vessels dictate your lifespan? Science calls this phenomenon shear stress. When you walk normally, the blood flow is simply too gentle to wake up your physiological barriers. Why is brisk walking the unique key that unlocks these chemical valves? What precise mechanism turns simple mechanical friction into anti-aging molecules spreading throughout your entire body? The medical data reveals a completely different picture of 30 minutes of intentional walking. If you are curious about how your body really works, hit that subscribe button to discover how speed reroutes your entire biological system. Imagine a highly complex car engine running in neutral. The fuel burns and the internal parts move, but the transmission is completely disengaged. The vehicle hums quietly, but consumes only the absolute minimum energy required to keep the engine turning. This is essentially your body during a casual daily stroll. Millions of us walk 10,000 steps a day at a leisurely pace, expecting significant health upgrades. We often assume that simply moving our legs is enough to optimize our biological systems. This seems perfectly logical. But what if the biological reality is far more demanding? Why do our cardiovascular systems maintain their current baseline when we walk slowly? The answer lies in the beautiful efficiency of human biology and a strict physiological principle called homeostasis. Your body is incredibly mindful of its energy reserves. It prefers to conserve metabolic currency whenever possible. Through millions of years of evolution, we survived by not wasting energy unless absolutely necessary. When you walk at a comfortable pace, perhaps under 40 steps per minute, you are merely coasting. The brain has automated this gentle movement so thoroughly that your motor cortex barely needs to engage. The heart beats just enough to keep you upright and balanced. The lungs expand just enough to maintain baseline oxygen levels. The entire system rests comfortably within its familiar limits. What happens if the physical demand never breaches this baseline? The body interprets this gentle stroll as the standard requirement for daily existence. There is no fundamental constraint forcing it to build new tissue, to manufacture new mitochondria, or to reinforce arterial walls. The blood flows calmly. The vascular walls feel no unusual pressure. It is a quiet internal environment. Why would a biological system allocate precious cellular resources to upgrade a network that is already handling the current load perfectly? It simply maintains the status quo. Strolling is a wonderful maintenance mode, but it is not a structural upgrade. Please note that comparing a stroll to a brisk walk is meant to highlight the specific physiological benefits of fluid friction, not to discourage gentle walking or other valid forms of movement. Any movement is highly valuable, but if we want to change the architecture of our bodies, we must introduce a novel stimulus. How do we convince a stubborn biological machine that it needs to rebuild itself? We have to introduce a physical demand that forces an adaptation. We have to override automation. Consider what happens when the velocity shifts. Imagine changing your pace from a relaxed walk to a brisk stride, as if you are trying to catch a departing train. You cross a specific mechanical threshold, reaching roughly 100 steps per minute. Your heart rate naturally elevates to a restorative zone, often within 60 to 85% of its maximum capacity. This is where the physiological automation is pleasantly interrupted. Your internal senses suddenly wake up. Your leg muscles unexpectedly require a noticeably higher volume of oxygen to sustain this crisp new rhythm. How does the body meet this delightful new challenge? The heart begins to pump with much more purpose and a larger volume. The amount of blood leaving the left ventricle increases significantly with every single beat. What exactly does this sudden fluid surge do inside the closed network of your circulatory system? Think of a flexible garden hose. When you turn the water on low, it glides smoothly through the center of the tube, barely interacting with the inner walls. But when you increase the flow rate, the water brushes firmly against the rubber lining. This is basic fluid dynamics. In the realm of physics, when a fluid moves swiftly through a constrained pipe, the friction it creates against the boundary is called shear stress. In human physiology, this mechanical friction acts as a fundamental master switch for cardiovascular youth. Let us zoom into the microscopic landscape of your blood vessels to observe this physical marvel. The innermost lining of every artery and vein is composed of a single layer of cells known as the endothelium. It is remarkably thin, yet it functions as an essential sensory organ. It is a highly active biological barrier. These endothelial cells are not merely passive wallpaper lining your veins. They are highly attuned mechanical sensors. They possess tiny microscopic hair-like structures that physically bend when blood rushes over them. How does a living cell translate a physical push into a sophisticated chemical response? When you walk briskly, the accelerated blood flow gently drags against these cells. The shear stress physically alters the shape of their lipid membranes. This precise bending is the primary language the endothelium understands. It does not process complex thoughts about your exercise routine. It simply registers the friction. This is a pure mechanical reaction. When this friction hits the optimal threshold created by a brisk pace, it signals the endothelial cells to shift out of their resting state. They initiate the activation of a specialized enzyme called endothelial nitric oxide synthase. What is the role of this specific enzyme? And why is it so critical to our cellular well-being? Its primary function is to gather passing amino acids from the blood and synthesize a fascinating molecule called nitric oxide. Nitric oxide is a signaling gas. It is highly reactive and exists for only a few brief milliseconds before it naturally dissipates. But in those fleeting moments, it completely reorganizes the geometry of your blood vessels. It is a brilliant chemical messenger. How can a temporary gas dictate the physical diameter of a solid biological pipe? Nitric oxide is lipophilic. This means it smoothly passes through cellular barriers without needing a specialized gateway. It diffuses out of the endothelial layer and melts directly into the smooth muscle cells that wrap around the outside of your arteries. Once inside these muscle fibers, the gas initiates a remarkable chemical cascade. It activates an enzyme that produces a secondary messenger molecule known as cyclic GMP. This messenger carefully regulates internal calcium channels. It gently ushers calcium ions out of the muscle fibers. This is a very precise cellular mechanism. Without a high concentration of internal calcium, a muscle fiber cannot maintain a rigid contraction. The smooth muscles enclosing your arteries naturally relax. The blood vessel widens. Science refers to this restorative process as vasodilation. The internal diameter of the pipe gently expands. What is the immediate physical consequence of expanding a pipe while fluid flows through it? The internal pressure naturally decreases. This is precisely why 30 minutes of brisk walking promotes a healthier diastolic blood pressure. The sequence is beautifully logical. Physical friction becomes chemical messaging. Chemistry creates structural expansion. But this fascinating process extends far beyond the blood vessels. Let us look at the leg muscles performing the actual physical movement. For many years, we often assumed that muscles were simply biological levers. We viewed them as tissues designed solely to move the heavy skeleton. This seems logical at first glance. But why would the body limit its largest tissue mass to mere mechanical lifting? The biological reality is far more elegant. Under the rhythmic demand of brisk walking, your muscles reveal their true nature. They function as a vast endocrine organ. This changes how we view human movement entirely. Imagine a damp sponge. If you leave it sitting on a counter, nothing happens. But if you gently squeeze it under running water, it releases whatever it was holding into the stream. When your quadriceps, hamstrings, and calves contract and release roughly 100 times a minute, they behave like brilliant biological sponges. They experience a healthy, repetitive mechanical load. What occurs inside a muscle cell when it contracts repeatedly under this specific load? The cellular machinery begins packaging specialized proteins and helpful microgenetic material into tiny lipid bubbles. These bubbles protect the fragile proteins from degrading in the blood. These are called extracellular vesicles. As the muscle fibers engage, they release millions of these beneficial packages directly into the bloodstream. Researchers call these specific molecules exerkines. How can a working muscle in your leg assist an entirely different organ on the other side of your body? Exercises are the fascinating answer. Because nitric oxide has already opened your blood vessels, these exerkins have a clear, expansive pathway to travel. They flow outward and circulate systemically. They act like guided biochemical messengers. Their journey is highly intentional. One of their natural targets is cellular maintenance. As time passes, our bodies naturally accumulate senescent cells. These are older cells that have paused their normal functions but linger in the tissues, sometimes contributing to a low level of systemic biological noise. They refuse to naturally recycle themselves. When the exerkins from brisk walking interact with these senescent cells, they gently encourage a natural process called apoptosis. They signal the older cells to naturally break down and clear out. The systemic noise quiets down. Liver function optimizes. Heart tissue maintains its resilience. This is deep biological housekeeping. You are not merely expending energy when you walk briskly. You are actively operating a biological pharmacy, synthesizing and distributing restorative compounds to various systems in your body. Now, let us trace the path of these exerkins as they flow upward into your body's most resource-hungry organ, the human brain. Many of us are interested in maintaining cognitive clarity as the years pass. We often rely on mental exercises or puzzles to keep our minds active. We assume that brain health is entirely about training the neurons themselves. This seems like a reasonable assumption, but what if cognitive preservation is also largely a matter of fluid dynamics? The medical community studies this through the lens of vascular cognitive impairment. Deep within your brain lies an intricate network of microscopic capillaries. They are so incredibly delicate that red blood cells must often fold themselves in half just to pass through a single file. Over decades of sitting or remaining inactive, these tiny pathways can become less flexible and occasionally blocked. When these microscopic pipes lose their elasticity, the neurons downstream struggle to maintain optimal function. They become slightly undernourished. Why does a daily crossword puzzle fail to resolve this physical constraint? Because a mental puzzle does not rebuild a physical capillary. It requires a physical stimulus. When you sustain a brisk walking pace, the rich supply of nitric oxide and muscle-derived exerkines reaches the blood-brain barrier. The brain registers this healthy influx of nutrient-rich blood and the supportive chemical signals arriving from the legs. It responds by initiating a brilliant physiological process known as angiogenesis. Imagine a dry plant root that suddenly receives a steady trickle of water and nutrients. It naturally sprouts tiny, fresh white rootlets to absorb the nourishment. Angiogenesis operates on the exact same biological principle. The brain constructs brand new microstructures. It builds new, highly flexible capillaries. It physically expands its own microvascular network. Blood flow seamlessly reroutes around older, less efficient pathways. The neurons receive a fresh, abundant supply of oxygen and glucose. The integrity of the blood-brain barrier is naturally reinforced, supporting a healthy environment for your delicate neural tissue. Memory and focus are supported not just because you exercised your thoughts, but because you improved the physical roads that deliver their fuel. The cognitive clarity you experience is a direct downstream result of this microvascular enhancement. It is a structural upgrade for your mind. However, this profound structural change does not become permanent after a single afternoon walk. The human body requires consistent mechanical signaling to justify a long-term structural adaptation. What happens when you provide this precise biological input every single day for 30 days? Think of the process like polishing a piece of rough wood. A single pass with a cloth might remove some dust, but the surface remains largely unchanged. Yet, if you apply gentle, consistent pressure every day, the wood eventually develops a deep, permanent shine. The 30-day accumulation of brisk walking introduces a completely new structural reality to your physiology. Let us observe the timeline of this quiet transformation. During the first 7 days, the adaptations are mostly internal and primarily chemical. Your body experiences healthy, temporary increases in nitric oxide production. The endothelial cells are awakening to this new mechanical rhythm. They might be slightly slow at first, gradually adjusting to the demand for rapid vasodilation. Why does a brisk pace often feel a bit tiring initially? Your heart is gently pushing against vessels that are still learning how to relax efficiently. The cellular enzymes are simply warming up, but by the end of the first week, the endothelial cells become highly efficient. They optimize their enzyme activity, manufacturing nitric oxide smoothly and abundantly. You may suddenly notice that walking up a familiar incline feels noticeably easier. The mechanical friction has successfully established a new chemical efficiency. As you transition into the second week and reach day 15, the adaptation shifts from invisible chemical signals to actual structural modifications. The architecture of your veins begins to change. The consistent daily presence of shear stress communicates to your circulatory system that this elevated fluid volume is the new normal. How does a single cell adapt to a constant rushing river? The endothelial cells actually begin to change their physical orientation. They elongate and align themselves perfectly parallel to the direction of the blood flow. Imagine a school of fish naturally turning to face a steady river current. This precise cellular alignment drastically reduces flow turbulence, allowing the blood to glide with incredible smoothness. It is an amazing feat of biological engineering. Simultaneously, the daily release of exerkines from your leg muscles begins to accumulate systemically in your blood plasma. The natural recycling of senescent cells in your deeper tissues becomes far more pronounced. Systemic markers of everyday metabolic stress begin to lower gently. The muscle fibers in your legs respond by building more mitochondria. These are the microscopic power plants that convert arriving oxygen into usable cellular energy. Your physical metabolic capacity gently but firmly expands. The energy grid is growing. By the time you reach day 30, a complete physiological shift has occurred. Your body's ability to utilize oxygen, often measured as VO2 max, has measurably improved. Your resting heart rate naturally settles at a lower number. Why does your heart get to rest more while you are doing more work overall? This happens because each gentle stroke of the left ventricle now effortlessly moves blood through an optimized, fully dilated network of highly flexible vessels. The pump simply does not have to work as hard to deliver the same volume. Furthermore, the capillary density in your brain has expanded, offering a beautiful structural reserve for your long-term cognitive health. You are functioning as a beautifully updated biological system. How did the body learn to sustain this new, elevated baseline? It did not simply memorize a psychological habit. It physically adapted its cellular machinery to thrive within a higher energy demand. The daily application of mild mechanical friction gently guided the entire organism to elevate its standard of homeostasis. The baseline has been permanently raised. This is the fascinating takeaway from a 30-day brisk walking routine. It invites a completely new perspective on human movement. A brisk walk is not just a casual pastime or a way to pass an afternoon. It is a precise, mechanical input that speaks directly to your cellular logic. The physical velocity generates the necessary friction. The fluid friction signals the mechanical sensors in the endothelium. The activated endothelium synthesizes the signaling gas. The gas relaxes the surrounding smooth muscle vessels. It is a perfect biological chain reaction. The newly opened vessels allow the active muscle tissue to distribute restorative exerkin molecules throughout the entire systemic loop. The brain, receiving this rich biological cocktail, builds new microhighways to utilize the arriving nutrients. This seamless chain of biological events naturally pauses when we return to a completely sedentary lifestyle. What happens when we stop moving with intention? If we remove the brisk pace, the mechanical friction decreases. Without the friction, the endothelial sensors go back to sleep. The signaling stops. The chemical production slows down. The vascular network slowly tightens and returns to its lower baseline. The system maintains itself, but it does not expand or repair optimally. Your body is a remarkable physical network, governed by elegant biological laws of physics and chemistry. It responds beautifully to rhythm, movement, and intentional mechanical load. It thrives when we provide the gentle physical signals that encourage it to rebuild and grow. 30 minutes of brisk walking is a surprisingly profound way to deliver that vital signal. It is exactly how we encourage our internal systems to continuously renew themselves from the inside out. If you found this insight valuable and want to continue exploring the brilliant mechanics of this biological machine, consider subscribing for more deep dives into the mechanisms of our world. We will keep diving into the fascinating, elegant logic of the human body. See you in the next deep dive. This content is for entertainment and educational purposes only and does not replace professional medical advice. Always consult with a qualified healthcare professional before beginning any new exercise regimen.